I'm glad to be virtually here with you all today. Let me first introduce myself. I work for HPE as a technologist on the Exascale HPC projects. These projects cover a lot of ground. My focus is on containers, orchestration systems, and user experiences. This talk will introduce the concept of using Jupyter infrastructure as a platform for system management, not the typical use case for Jupyter. As we started to look at system administration and use cases, we took a look at the whole administrative experience and found that many applications could benefit from adopting newer technologies, in particular the Jupyter Notebook infrastructure, from repeatable tasks, illustrative examples, data analysis of system data. Another compelling use case is in the shareability of operations between the sites. Many tasks are common, albeit with a few tweaks, so why not share and collaborate? Looking at the motivation for the project, the question was, what can we bring to the user experience? Provide a web interface to the system and using APIs and CLIs and the monitoring infrastructure, as well as a customizable environment and tool sets. Provide a single framework for the provider, customer, and the community for administration activities and collaborations. Create a platform that can easily integrate different data sources, compute, analysis, and visualizations, all in a single environment, and bring together elements of system management such as control, monitoring, and analysis. Let's look at some guiding use cases. Define a set of prescribed commands and actions as notebooks. These would include system administrative tasks, boot, status, inventory, system information such as accounting and dump, general logging, telemetry and search capabilities, action-based scripting with analysis for user job data, system triage, and collaboration. Share documents and results with others using version control. Administrators and operators have a single access pattern to the system, typically via a terminal or through a proprietary web-based interface such as HPILO. For system users, the choice is somewhat more flexible via terminals, consoles, network protocols such as SSH, browsers, and notebooks. What we are introducing here is the idea of using some modern technologies in conjunction with existing methods to help the administrator navigate these complex systems. Let's take a look at the administration data sets, these being system management data, platform data. In this case, we are using Kubernetes as the platform for the system management infrastructure, system telemetry data and events. Integrating all these data sources under a single structure is the key goal. Having a single framework able to provide access to system data integrated into the system administration infrastructure through CLIs and RESTful APIs and its data sources, as well as bringing together a rich set of tools for analysis and presentation, is a powerful idea. Let's take a look at the architecture. Remote access. Remote notebook instances, RESTful connections to administration APIs and CLIs, remote HTTP and HTTPS access to notebook servers, notebook storage, both internal and external, and different session types. We have interactive session types and also event and schedule-based operations. Here's a picture of the administration environment. We have remote notebooks coming in using RESTful APIs through the API gateway into the system and system management services. We have the typical access pattern of using a web browser to access the Jupyter framework. And again, within the Jupyter framework, we can access the system management services through local REST calls. And also we have introduced a workflow manager. In this case, it's Apache Airflow in conjunction with PAPERMILL to be able to run scheduled notebooks in the background in a headless manner. Part of the operation pattern for these systems is to perform repeatable tasks. Cron has been the traditional tool of choice. Another use case is the ability to react to system events, the ability to trigger some process for post-mortem and analysis. A quick intro into PAPERMILL. Basically, in a few words, PAPERMILL represents notebooks as callable functions. PAPERMILL isolates the inputs and outputs, allowing notebooks to be executed in a headless manner, and the source of the rendered output to a named document. Meaning, PAPERMILL takes input source, executes all the cells in order, and the output to a named notebook. Also having the ability to templatize your notebook, where you can have parameterized notebook inputs. So in summary, PAPERMILL adds notebook isolation, immutable inputs and outputs, parameterization of notebooks, notebook runs, configurable data sources and sinks for data management. So to wrap up the presentation here, we have a few examples. The first example shows a Python library to access system configuration data and display it in a simple table. We provide a set of template notebooks, we call them pamphlets, for visualization of content management data as well as telemetry and log records. We also incorporate data analytics into these pamphlets to determine system health and monitoring of subsystems. In this case, we are searching telemetry data and running some basic system analytics. The top display is using Prophet, an open source library from Facebook for anomaly detection using a time series data. So in conclusion, we believe the use of Jupyter as a platform for system management will bring value to our customers and add a new dimension to system administration services. Thank you for your time. I hope you've enjoyed the presentation.